Hello dear friends, today I'll show you the topic permutation. We start with combinatorics and we stopped here in permutation. What is permutation? As I wrote here, arrangement, changing places or positions, we can say permutation. Okay, if we have n elements, how we can do this? Let's read the definition. An ordered arrangement of some or all elements of given set is called permutation. And usually, as you learned, we use here what? Factorial. That means permutation of n elements. It can shown in two ways. This first one is the second one. Pn is equal to or Pnn. That means permutation of n elements among n elements, we can say. So it will be, we can multiply all elements from 1 to n. That means 1 times, 2 times, 3 times, 4 times, 5 times, and so on, n minus 2, n minus 1, and n. Shortly, we can say n factorial. You know everything, these things. Now, how we can understand clearly? Let me give an example here. Here we have an example. What is he said? Here is another example of permutation problems. In how many different ways can the three students, Farooq, Alek, and Evgeny, be seated on a desk? For example, we have three students. Okay. We can imagine this as it's given here. Look, we can do this one. First, look, let's imagine this is Farooq, this is Evgeny, this is Alek, okay? First seating, second, third, fifth, fourth, fifth, and sixth one. That means they can sit in different 6 ways. That means they can change their places. Actually, we can say, using the permutation, how we can we can solve this one. Look, let me take this one here. Farooq, and how many students we have here? 3. So n is equal to 3. If n is equal to 3, we can say permutation of 3 students, 3 things, we can say, or 3 places. We are changing their places. Or short, we can write p3 to 3. So what it will be? We can say 3 factorial. It will be 3 times 2 times 1 is equal to 6. You see, we had here 6 different seatings, and also here we have 6. You see? Okay, this is the first example. What about next? Here we have next example. How many different 8-letter permutations are there of the letters in the word Istanbul? How many 8-letter permutations? So that means we should make permutations of 8 letters. Look, let me divide this given line into 8 pieces, okay? To make, we should put every letter. Look, in the word Istanbul, we have 1, 2, 3, 4, 5, 6, 7, 8. All 8 letters are different, not same. So we can say we can put, for example, it's the one of the examples for Istanbul word, 8-letter permutations. It can be Tisanbul, for example, Bisanul, for example, this kind of things. Okay, so how many letters we have here? Firstly, 8, and then 7. That means if you put one of the letters here, for example, I cannot put I here. It's already here. For example, L is here. I cannot put L in other these 2 places. Okay, it will be. It continues as 6, 5, 4, 3, 2, 1. Or shortly, you see, we have ordered numbers from 1 to 8. So we can shortly we can say 8 factorial. You see, it is 8 factorial. If you multiply all numbers, that means 8 times, 7 times, 6 times, 5 times, 4 times, 3 times, 2 times 1, you will have 40,320 permutations. Let me stop it here. That means different word arrangements of these words, okay? Or short, you can stop, you can leave as this given. What? Next. Next example for you. Here we have another example. 380 on your book. You can see also this example. A football league has 18 teams. A football league has 18 teams. How many different rankings from the first to last are possible in the end of the season league table, assuming that there are no ties? It's the same thing. Each football team is distinct. That means they are different. All teams are different. That means, you see. So if you are going to arrange all teams, we have what? 18 places. So 18. For example, let's see. It's the first team is Barcelona. Second team is, for example, Chelsea. It's this kind of things. Okay. So Barcelona at the end of the season, it can be the first one. It can be the last one. It can be in the middle. Okay. It can change these places. So we have permutation of 18 teams. That means 18. It will be 18 factorial. You see? That's all. This is the solution. Or shortly we can write, among 18 teams, we should arrange to 18 places. So it will be 18 factorial. If you count, that we multiply from 18 to 1, it will be a very big number. You don't need. So we can say, we can write possible rankings. Okay, thank you. This is the answer for the given example, the 180. You have all these examples on your page, on your book, page 341. Thank you. Next example for you, to understand clearly this topic. Look, we have Murat has 5 different math books. That means what kind of math books it could be? For example, it could be geometry, logarithm, for example, it can be derivative, integral, and that means all different books has the what? Books have the different titles of the books, for example, different. They are not same. See? 3 different biology books. It can be zoology, for example, as I know, different, we can say, isn't it? So, and 4 different physics books. They're also different. In how many different ways can Murat arrange his books? That means we have 2 questions firstly. On a bookshelf. Here is an example for you. Here is a bookshelf. That means, firstly, on a bookshelf. It's not saying the different thing. That means there's no, we can arrange in any way. Okay, look. 5 math books. They are different, all of them different. And 3 biology books. Again, they are all different, isn't it? And also 4 physics books. Again, yes, they're all different. You see? Yeah. How many different books we can have? How many different books? 5 plus 3 plus 4 is equal to 12 different books. Okay? So 12 different books. For A, on a bookshelf, that means Murat arranged his books on a bookshelf. That means there is no difference about the subjects. They're all different. We can say that we have 12 different books. And we have to arrange into 12 places. So it will be 12 factorial. See? It's easy for this one. What about B? In 3 different file holders. Look, first file holder, second and third. You see? So if each holder is for a different subject. if each holder is for a different subject. See? Now we have to arrange them. That means permutate them differently. For example, first mathematics. How many mathematics books we have here? 5, and 5 of them different. What about this one? In biology, we have 3 books. All 3 books are different. What about physics? Physics are also different. Yes, 4 to 4, we can see. You see? They will be arranged among these 5 books. And firstly, for example, geometry, second integral, and so on. Or first integral and second geometry, and so on. Okay? It will change it, this kind of things. So, places. And also, we have to multiply them all. That means, let me write here, this is math arrangement. This is bio. This is what? Arrangements of physics. Okay? And also, we can change the places of these subjects. For example, first we can put mathematics, second bio, third physics, or we can first put physics, then bio, then mathematics, and so on. Okay? And also, we have 3 subjects, and we should arrange their places again. It's the same example for the first one, which we arranged the 3 students among these places. Same thing. So we'll have here 5 to 5 means 5 factorial, 3 to 3 means 3 factorial, 4 to 4 means 4 factorial, times the end. We arrange all these 3 things, that will 3 factorial. Or 5 factorial, if you multiply from 5 to 1, it will be 120. 3, if you open, this one is 6, this one is 24, again 6. If you multiply them all, you'll have 103,680 arrangements. Okay, arrangements. See, this is the first one. See, you are first arranging all books. The second one, you are arranging just what? By subjects. And 3 different file holders. So that's okay. Now this was the topic for permutation of n elements. We had, for example, I gave you different examples, which are all these examples on your book. You can continue, and homework for you is check yourself 84 you have on your book, page 341. Page 341. Okay? You have 3 different examples, more according to this topic. So, thank you for listening.